Okay, so goodbye. Today we are going to start with the finding equilibrium concentrations. So we are given the equilibrium concentrations of the reactants, and sometime we have to find out the equilibrium concentration for the products. And sometime we are given the equilibrium concentrations of the reactants and the products, and we have to find out the Kc for any chemical reaction. Just like goodbye, you can see at the slide number 2 that we are given an equilibrium question in which we have the reaction between the ethanoic acid and the ethanol, and it reacts together to form the ethyl ethanoate along with the water. So the question says that you are provided with the volume of solution is 500 centimeter cube, and along with that you are given the equilibrium. At equilibrium, the mixture contained the 0.23 moles of ethanoic acid and this 1 mole of the ethanol.
I can't hear you.
Sorry,
I can't hear you.
you can't hear me?
Now I can.
Okay, right. So you are given the equilibrium concentrations of the products. No, equilibrium concentrations of the reactants are given to you, and equilibrium concentration of products are also given to you. So you have to find out the value of the Kc. So what we have to do is, at first we have to use the data that is provided to us to find out the concentration of the we have to find out the value of the Kc by using this piece of the data. So what we can do, basically we have to convert the number of moles of the reactants that are given to us into the molar concentration, because yesterday I have told you that we are always going to use the concentrations of the reactants and the products in the form of the mole per dm cube. But you can see that in this one case they have provided you the number of moles of ethanoic acid, number of moles of the ethanol, and they have provided you the number of moles of ethyl ethanoate and the water. So goodbye, what we have to do, we have to convert the number of moles into the molar concentration. So jump to the next one slide. So can you tell me that how we can convert the number of moles into the molar concentration? So can you tell me?
It is more concentrated is number of moles over volume.
Yeah, very good. So we have this one formula, that is N is equal to C into V, right? So we can use this
Yes.
one formula to convert our given number of moles into the molar concentration. First, we can rearrange this one equation. So the C is equal to N upon V, right? But keep in mind that the volume in this one expression, it should be in the decimeter cube. Got it? So in the question you have seen that the volume was given to us, but it is present in the form of the centimeter cube. So we have to convert the volume is provided to us, but that is 500 centimeter cube. So goodbye, can you tell me that how we can convert the volume from the centimeter cube into the decimeter cube?
By dividing by 1 million.
Dividing with what? No.
Dividing by 1,000.
Yeah, dividing by 1000, not the 1 million. So you have to divide it with the 1000. So what would be your answer?
It will be 0.5.
Yeah, it's 0.5 decimeter cube. So now you can easily convert all the number of moles that are provided to you into the molar concentrations, right? So we can divide the number of moles of acetic acid, we can divide the number of moles of ethanol, eth- uh, number of moles of ethyl ethanoate and the water. So we can separately do for all. So we can say that the concentration of, or we can say that it's the first for ethanoic acid. If we put the square bracket around it, it would be in the form of the mole per dm cube, right? So the goodbye, can you tell me? Move to the previous one slide. You should move to the previous one slide and let me know about the concentration of the number of moles of acetic acid. How much it is?
Yes, I know it.
Mm,
Acetic acid it is 0.235.
235.
This is the number of moles.
Yeah, so it would be divided by the 0.5. So the answer comes out to be the, it is equal to 0.47. So 0.47 mole per dm cube. In the same way, we can find out the concentration for the ethanol. H5OH. Goodbye, let me know the number of moles for the ethanol.
It is 0. Ethanol. It is
Hmm.
0.182.
182 divided by 0.5, and this one comes out to be the, no, goodbye, the concentration of ethanol is 0.035.
Salt is ethanol.
Oh, it is 0.035, and it comes out to be the 0.07 mole per dm cube. In the same way, you have the ethyl ethanoate, C2H5 COOCH3. The number of moles of this one are 0.182. It will be divided by the 0.5, and it would give you the value of the 0.364 mole per dm cube. And the last one is we have to find out the concentration for the water, and its number of moles are it is also the 0.182. So it will be same for both. Yeah, divided by 0.5. That comes out to be same, 0.364. Okay, so there are the four molar concentration provided to you. Okay, so now we can easily put these concentrations into the balanced into the equilibrium constant expression. Okay, so could we move to the next one slide? So we have this one, balanced chemical equation, that is uh, CH3 COOH it reacts with the C2H5OH reversible reaction, and you would get the CH3 COO C2H5 plus the water. Goodbye, can you tell me that how we can write down the Kc expression for this one?
Should be CH3 COO C2
Hmm.
H5 in brackets.
So CH3 COO C2H5 concentration
And also beside it water in brackets.
multiplied by water.
Divided by mass reactant in bracket.
Right, this one C2H5OH. So we can simply put the values of the molar concentration that we have got at the previous one slide here, and you would get the value. So for both the products, you have got the value 0.364. We can say that 0.364 multiplied by 0.364 and divided by the concentration of the reactants 0.47 and 0.07. 0.47 into 0.07. Okay, so when we simplify the equation, when we multiply them and divide them with each other, so the answer that we get is the 4.03. Okay, so the answer comes out to be 4.03. This is the value of your Kc. Okay, so goodbye. Let me know that whether this one Kc would be having any unit or not. Whether this one Kc is having any unit.
No, it will not have units because the number of moles in the right is the same as the number of moles in the left.
Very good. So we can say that no unit because the number of moles are equal on both sides of the equation. So that's why it has no units. Okay. So we can say that you have got the idea that in this one manner you can easily find out the value of Kc if you are provided with the molar concentrations of the reactants and the products. Got it? Okay. So now we can go to another one question which is related to the same calculation of the Kc. So goodbye, move to the next one slide. The propanone reacts with the hydrogen cyanide as this one. So a mixture of propanone and hydrogen cyanide. So initial concentrations of the propanone and the hydrogen cyanide are provided to you, and it is said that at equilibrium the concentration of the product, so concentration of product is also provided to you, but it is at equilibrium. So you are provided with the initial concentration of the reactants and you are provided with the equilibrium concentration of the product. So now goodbye, keep in mind that in the Kc expression you are not going to use the initial concentration of the reactants. Instead you have to find out the equilibrium concentration of the reactants, then you can use them in your equilibrium constant expression. Got it? So it means that we can say that at start we were having the uh, how much concentration of the propanone. So we can solve this one question on the next one slide. So move to the next one slide. So the first one point what we have to do is we have to write down the balanced chemical equation again, because we have to find out the equilibrium concentrations of the reactants, and then we can use them to calculate the uh, our Kc value. So what we have the propanone. So goodbye, can you tell me that propanone belongs to which one homologous series of the organic compounds?
is halide,
No, goodbye, keep in mind that it's a
what?
ketone. It's a ketone.
Ketone.
Yeah,
What is ketone?
ketone.
Ketone.
Yeah, it's a ketone. So CH3COCH3, this is the formula for the propanone, and along with that you have the hydrogen cyanide HCN, and when it would be reacted in a reversible manner, so you would get a cyanoalcohol CH3COH. This one is the CH3 C and OH, and along with that it's the CnCH3. It's a cyanoalcohol, and it is said that the initial concentration of both the reactants are provided to you. 0.05 moles of both are provided to you. So at start we can say that initial concentration is provided. So initial concentration, it is 0.05 mole per dm cube. In the same way, the HCN is also the 0.05 mole per dm cube. And goodbye, can you tell me that what is the initial concentration of the product?
It's a product.
Hmm.
Should
When when you
this one
just when you just started the reaction, so how much would be the product present in the reaction mixture?
should be one.
No, it would be zero, because we have just started the reaction. So at the start of reaction, the product is zero. Got it?
Yes.
So it is zero. So we can say that now we have to find out the equilibrium concentration. Equilibrium concentration. Okay. Equilibrium concentration is of the reactants are not provided to you, but you are provided with the equilibrium concentration of the product, right?
Yes.
It's 0.023. So 233 mole per dm cube. So now we have to find out that how much reactants are present. Goodbye. If you have a look at the stoichiometry of equation, so what you can deduce that what is the stoichiometric ratio of the reactants and the products.
Sister, can you repeat the question because we are lagging?
I was saying that what is the stoichiometric ratio of the reactants and the products if you have a look at the balanced chemical equation?
It is 2 to 1.
No, no, it's not 2 to 1. You can see that if 1 mole of uh, propanone reacts with the 1 mole of the hydrogen cyanide, so you get the 1 mole of the product, right? So it means that the ratio is 1:1. Got it?
But there
Okay.
is 2 moles in the left.
No, no. Which one? Good boy. When you have to find out the mole ratio, so mole ratio is calculated between the one reactant and the product, and then the other one reactant and the product. It's not that you would combine the two reactants together to find out the mole ratio. Mole ratio is the ratio between the product and one of the reactant. So you can see in this one reaction that
Then
there.
I can't hear you. Well,
Good boy, why you can't hear me? Internet is working on my side, so you still can't hear me. Hello, Mazen, can you hear me?
yes.
Okay. So the stoichiometry of the equation says that there is the 1-1 ratio. So it means that if
So
the.
they are still lagging.
Mazen, give me a minute. So if we talk about the stoichiometry, so I was telling you that there is the 1:1 stoichiometry between the products and the reactants. So if at equilibrium the 0.023 moles of the products have been found, so it means that the same number of moles of reactants have been converted into the products. Got it?
Yes.
So we can say that the molar concentration of the reactants at equilibrium would be 0.05. Mm, it is 0.05 minus the amount of product formed. So minus 0.023. And in the same way, you can do for the other one reactant. So it gives you the answer of the about 0.026. So this becomes 0.026, and the other one concentration of the second reactant, it would also be the same, because you know that the number of moles of reactants or the concentration of the reactant that was used, it is same. So the other one would also become the 0.0267. So the concentration of other one is 0.0267, right? So it means that at the equilibrium you have this molar concentration and this molar concentration for your reactants, and this is the molar concentration of your products. Got it? So now you can easily use these values of the molar concentration to find out your Kc. Move to the next one slide. So we can write down the Kc for this one. So its Kc is still very simple because there are no coefficients involved in this one. So it would involve the molar concentration of the cyanoalcohol, the product. So that is its value is 0.023. So 0.023, it would be divided with the molar concentration of the reactants, that is 0.026, into the same for the other reactant 0.026. And if we do the calculations for this one fraction, so what we would get, its value comes out to be 32.7. 32.7. Okay, so goodbye. Now move to the previous one slide and let me know that whether this one Kc would be having any unit or not.
It will have unit.
Yeah. So now move to the slide number 7, and here we can decide that which one would be the unit. So can you predict the unit, or we have to solve for it?
Should be decimeter cube minus 1.
Hmm.
Wait, mole minus 1
Hmm.
decimeter cube.
Right. So per mole and decimeter cube. So this is the value of the Kc for your provided question or the provided equilibrium system. So now we can talk about another one in which we are provided the same situation. So move to the next one slide. So you are provided this one equilibrium system in which all the gases are involved. So initial concentration of the reactants are provided to you, and the equilibrium concentration of carbon monoxide is also provided to you. But equilibrium concentration of water is not provided to you. So how we can solve this one?
By using the same step.
Yeah, by using the same steps. So move to the next one slide. So first, what we have to do, goodbye, can you do this one in your homework?
Okay.
Yeah. So we can start with the next one point for our topic. So you can do this one in your homework. Okay. So now we can talk about the effect of molar concentration or change in the concentration on the value of Kc. So first we are going to relate with the Kc and the concentration changes. And concentration change. So goodbye. It is discussing that if we talk about the value of the Kc, so if we change the concentration of the reactants that are provided to start with the reaction, so whether the value of Kc would vary or not.
Can I repeat the question?
I'm saying that if we change the concentrations of the reactants, the initial concentration of the reactants, so whether the value of Kc changes or not,
No, it will not change.
it would not change. So we, just like we have discussed yesterday about a situation in which we use different concentrations, initial concentration of the hydrogen and the iodine, but the value of hydrogen iodide, the concentration of hydrogen iodide, it changed, but the value of the Kc remained the constant throughout the uh, mm, different sets of the experiments we performed. The five or four or five experiments were performed, but all the experiments led to the average value of the Kc being the same. So we can write about this one, that value of Kc remains constant despite changes in the in initial concentration of reactants if all other conditions conditions are kept constant. So if you are keeping all the other conditions for the reaction as the constant, so if you would increase or decrease the initial concentration of the reactants, there would be no change in the value of the Kc. Got it? Okay. So the next one thing is if we talk about the Kc and the pressure change. So if we have a gaseous equilibrium in which the number of moles of products are not same on both sides of the equation, so we can take example of a chemical equation or a process. Mm, okay, so we can say that in gaseous equilibrium with different number of moles on both sides of equation, pressure changes change the position of equilibrium, right? Change, or you can say that the shift position of equilibrium. But now the question is that if we keep the temperature constant on such an equilibrium process, so whether there would be a change in the value of Kc or not, so it is said that the value of Kc would no longer change because it is just the change in the volume, because when you would change the pressure there would be the change in the volume, but the value of Kc would remain constant if temperature is not changed, because instantly there would be the change in the position of equilibrium, but after some time the equilibrium would again shift it in such a manner that it would keep the value of Kc constant. So value of Kc remains same if temperature is kept constant. Do you get it?
Yes.
Kept constant. Okay. So the next one thing is if we talk about the Kc and the temperature change. This is very important. Okay. So if we talk about that how the temperature would affect the Kc, so it is said that if we talk about the endothermic reaction, so we can take the example of an endothermic reaction that is 2Hi reversibly decomposes to form H2 and I2. And this is an example of the endothermic reaction. So if you would increase the temperature increased. So what would happen if it is an endothermic reaction?
And the ceramic, it will move to the right.
It would move to the right. And goodbye, keep in mind that if we talk about the temperature changes, basically temperature is related to the you can say that the enthalpy of reaction. So if the forward reaction is an endothermic reaction, so it means that add added temperature would add into the equilibrium, and the more and more amount of the product would be formed. So it is said that if you would change the temperature, then that added heat would involve in the enthalpy of the process. So we can say that because of it, the relative amount, or you can say that the uh, stability of the products, it would be increased at the high temperature. So we can say that more products are formed. More products formed. And let me know that if we write down the Kc for this one reaction, so it's Kc is equal to H2 and concentration of I2, and that's divided by concentration of hydrogen iodide and raised to power 2. So goodbye, let me know that if the temperature would be increased, so what would be the effect of increase in temperature on the value of Kc?
It will increase.
Yeah, so we can say that Kc would increase. So for the endothermic reaction, if you would increase the value of the temperature, Kc would increase. So now we can take the example of an exothermic reaction. So that can be taken as the SO2 combines with O2. So 2 moles of SO2 combines with O2 reversibly makes 2 moles of SO3, and it is said that it is an exothermic reaction. So it is exothermic. And the second piece of information that is provided to us, that temperature increase. So what do you think about this one? If temperature would be increased, so whether products would increase in the concentration or the reactants would increase.
The reactant would increase.
Yeah. So we can say that reactants favored and increase in concentration. And increase in concentration. If we write down the Kc for this one reaction, so Kc is equal to molar concentration of SO3 raised to power 2 and molar concentration of SO2 raised to power 2 and molar concentration of O2 raised to power 1. So goodbye, let me know that if the temperature would increase, so whether the Kc would increase or it would decrease.
It will remain constant.
Sorry?
Is the temperature or is the concentration?
No, I'm saying that temperature increased.
So if the temperature increases, the Kc will decrease.
Very good. So we can say that Kc would decrease if you would increase the value of the temperature, right? So for exothermic reaction, the increase in temperature uh, decreases the Kc, and for the for the endothermic reaction, increase in temperature increases the Kc, and for exothermic reaction, increase in temperature decreases the value of Kc. Got it?
Yes.
Okay. So goodbye. This was all about our today's class. Got it? So I would also put a question related to the shift in the position of equilibrium, effect on the value of Kc by changing the temperature and by changing the pressure, right? And you have to solve the question that I have left at the previous one slides as your homework, right? So send me that questions back in the WhatsApp group before the next one class. Got it?
Yes.
Okay, goodbye. So